Hi, my name is Xinglong.
My name is Churan, and this is our ECE 3D5 final project demo. And our project is a fish hunter game on the FPGA board.
Okay, so this is currently the main menu of the game. So, we have two sub-menus. The first one is the playing game menu, and the second one is the high score table. So, after I hit enter, so we can say that there are various fish moving in the ocean, and I can press the spacebar to store power and shoot the cannonball of varying distance. So I will show how to actually catch a fish. Yeah. And so as you can see on the upper right corner, we have a score counter and the time counter. And so one thing to notice about our game is that basically everything is randomized. So basically every fish is randomly regenerated, and the movement of each fish is also personalized. So each fish is moved at a randomized speed, but however we randomize each fish speed within a certain range. So the speed of the lowest point fish still moves slower than the most valuable fish. And so as you can see, the game I just played, the score of the game that I just played is stored in the high score table.
Yeah, another thing to notice is every fish has its own animation. And to do this, because we are kind of drawing so many fishes in the one screen, we implement a double frame buffer for our game frames. Is the connection between the hardware and software, in our case, which is the Avalon Draw interface. In that interface, the interface is mainly handled for draw the graphics on the screen, and it takes 8 parameters. The first parameter is the draw index, which is the index of the pattern that we store in our SRAM. The next parameter is the draw x start position, which means and it is the start position in the x-axis. The corresponding next parameter is the draw y start position, which is the start point in the y-axis. So we have the start point in the x-axis and y-axis. We also need the end point on the x-axis and y-axis. They are the basic draw positions and index of the parameters. So the other three parameters, frame down, draw down, and draw start. These 3 parameters can help our blader to know that what is the time to draw a new thing, and also our frame buffer to update the second buffer with the first buffer.
So this is the software part of our final project, and our software part handles the main game logic and the high-level drawing. So by the high-level drawing, I mean the low-level drawing specifics will be handled by the hardware drawing system. And so in this software part, there are several points worth noticing. The first one is the modularization. So we keep every basic structure of our game into structs and the prototypes. And so as you can see, in the playing game mode, each fish has its own struct. So we keep several features of the fish, its moving speed, its moving trajectory, and the regenerated position in the struct. And we also has the moving and the rotating cannon, and this cannonball struct. And also, of course, the fish net struct. So using this struct, we can quickly populate each object, and so we managed to handle multiple objects showing in the same VGA frame at the same time. So there are also several other points worth noticing. So the first one is that we can adjust the power, the maximum distance that can be traveled by the cannonball by pressing the space bar by different durations. And so I can hit the cannonball at the middle of the route, and okay, so this current game is actually over. And so I can also shoot the cannonball at its maximum power, which will travel to the top of the screen.
Yeah, to illustrate how much power do you have, it's like we have LED indicators to show the power. So as you can see, as I press down the power bar, you can see the LEDs is a kind of light up from the beginning to the end. You can see. So if I want to kind of shoot the cannonball at a certain power, I can just hold the space bar, wait, and release the space bar.
Like the maximum distance that can be traveled by the cannonball actually varies depending upon the current degree of this cannon. And so as you can see, at this 90th degree, at this vertical position, the maximum distance that can be traveled is like to the top of the screen. And like, so at about this degree, okay, so I will restart another game. So at this degree, the maximum distance that can be traveled, okay, yeah. So the maximum distance that can be traveled is actually like, so the left edge. Okay, so this is the end of our final project demo. And if you are interested in learning more about this project, you can find more details in our final report. And we will also show some of the source codes in the GitHub. Thanks.
Thank you.